Alright, here's another example of finding the area of a segment. In this case, we are given two circles, both of whose radii are 4 centimeters. And the area of the shaded region, if you take a look, can be found by adding the left half and the right half together. The left half is the segment that belongs to the sector on the right. And the right half is the segment that belongs to the sector on the left. So really, if we can find the area of this segment and add them together, we'll be able to find the area of the entire thing. So how do we find the area of the left segment first? So let's draw the left segment first. Something like that. And this is the center of the circle. This is the radius, 4 centimeters. Right here as well. This is the chord. And this is the left half of the shaded part. And we know that this right here, the base, is also given to us, which is 4 centimeters. It's kind of difficult to see, but it's 4 centimeters right there. So the base of this triangle is already 4 centimeters. So how do we figure out the height? Well, before we can even do all of that, we know that the area of this left segment is equal to the area of a sector minus the area of a triangle, which is the central angle theta divided by 360 degree total, multiplied by pi, multiplied by the radius square, minus 1/2 times the base times the height. So how do we figure out the central angle? How do we figure out the height of a triangle? Because we don't know the base. Well, if we take a look at this triangle here, all 4 sides are the same. So this is an equilateral triangle. So that means this angle has to be 60. This angle has to be 60. And of course, the leftover has to be 60 as well. Because remember that the definition of equilateral triangle says that if you have an equilateral triangle, then the 2 angles at the bottom of a triangle have the same degrees. Because those 2 angles have to have the same degree, and because the sum of all the angles of any triangle had to be added up to 180 degrees, of course, it makes sense that this has to be 60, 60, and then 60. Now, how do we figure out the height of a triangle? Well, just draw the apothem again, like that in the red. And know that the apothem and the base of a triangle intersect each other perpendicularly. So there's the right angles in the red right there. So to figure out the height of a triangle, just, let's say I want to pick the bottom half. So take the bottom half, draw it, and maybe it's going to look something like this. This is 4 centimeters. And this right here is the apothem, which is the height of the triangle. This is the right triangle right there. This angle is this one, 60 degrees. If this is 60, this is 90, this has to be 30, like that. By the 30, 60, 90 triangle, opposite to 30 degrees is a short leg, although it looks a little longer than the long leg here, but it's because of my drawing. But opposite to 30 degrees is a short leg denoted by the letter X. Opposite to 60 degrees is a long leg denoted by X times square root of 3. And opposite to 90 degrees is the hypotenuse of this triangle, which is also the radius of a circle, and it is denoted by the formula 2 times x. But this hypotenuse here is actually 4 centimeters from up here because it's the radius of a circle. So we get to take 2x and set it equal to 4 centimeters like that. Well, solving for x, that's going to give us x equals to 4 over 2, which is equal to 2 centimeters. So the short leg is 2 centimeters. Well, if x is 2, then we know that the height of a triangle is going to be 2 times square root of 3. Like that. Well, guess what? Just plug it in to the formula. So we know the central angle is 60 degrees. So just let's continue from here. That's going to be equal to central angle 60 degrees divided by 360 multiplied by pi multiplied by the radius, which is 4 raised to the second power, minus 1/2 times the base. Well, we know the base of a triangle is 4 centimeters as given. Times the height of a triangle, which is 2 times square root of 3 that we found. Like that. Well, to simplify a little more, we know these two cancel out. Let's see. Mental math. 60 divided by 360 is 1/6. 1/6 times 4 raised to the second power, which is going to be 16. So we got 16 pi over 6 right here. Minus, well, we got 1 times 4 times square root of 3, which is going to be just 4 square root of 3. This fraction on the left here can be can be simplified out even more by recognizing that the greatest common factor that goes into both 16 and 6 is going to be 2. So 16 divided by 2 is going to be 8. 6 divided by 2 is going to be 3. So 8 over 3 pi minus 4 times square root of 3 centimeters square. So this is the value of the area of the left segment, assuming that we are able to leave the answer in terms of pi. Now, what about the right segment? Well, finding the right segment is going to be very similar to finding the left segment. Like that. There. And like that. So this right here is the right half of the shaded part in the original picture. And we know that the base of this triangle is 4 centimeters. We know the radius is 4 centimeters as well. Well, guess what? This is an equilateral triangle again. So we know that by definition of equilateral triangle, we know this angle here has to be 60 degrees. This angle here is also 60 degrees. Of course, if this is 60, this is 60, then by the triangle angle sum theorem, this has to be 60 as well. So the area of a right segment is equal to the area of a sector minus the area of a triangle, which is central angle theta divided by 360 times pi times the radius square minus the area of a triangle, which is 1/2 times the base b times the height h. We know the base is 4 centimeters, so how do we figure out the height? And we know, like the radius is 4 centimeters. So to figure out the height, same thing, draw the apothem. And the apothem intersect the base of a triangle perpendicularly. So there's the right angles at the point of intersection right there. Selecting the top half of this triangle, we can draw it. Maybe right here. Hopefully my drawing is not that bad this time. Like that. And that's the apothem, aka the height of the entire triangle. This angle here is 90, right there. This angle right here, which is from this one, is 60. If this is 90, this is 60, the leftover has to be 30. By the 30, 60, 90 triangle property, opposite to 30 degrees is a short leg denoted by a variable x. Opposite to 60 degrees is a long leg denoted by the formula x times square root of 3. Opposite to 90 degrees is a hypotenuse, which is also known as the radius of a circle, denoted by the formula 2 times x. Well, we know the radius is also 4 centimeters, so we get to set 2x equal to 4. Solving for x, we got x equal to 4 divided by 2 equal to 2 centimeters. So the short leg equal to 2 centimeters. And the long leg, which is also the height of the entire triangle, is going to be 2 times square root of 3. Like that. So this is the height. So with the radius being 4 centimeters and the base being 4 centimeters of the entire triangle, and the height being 2 times square root of 3, just plug everything in. And the central angle being 60 degrees, of course. this is going to be equal to 60 degree divided by 360 degree times pi times radius 4 square minus 1/2 times the base 4 centimeter times the height 2 square root of 3. But wait a minute, this is exactly the same expression that we did just now. See? They're the same. So really, I know for sure this is going to be equals to 8 over 3 pi minus 4 times square root of 3 centimeters square. So with all the work now shown, in reality, we know for sure that these two halves of this shaded part are identical. So there are two ways to find the area of the shaded part. We can take each value right here, both of the left half and of the right half, and we add them together. Or we can just take the value of one of them and multiply that by 2, because you know both values of both halves are the same anyway. So the area of the shaded is going to be, let's see, 8 over 3 times pi minus 4 times square root of 3 plus the area of the right half, which is technically the same thing. 3 pi minus 4 times square root of 3. And let's put it inside of parentheses like that. Well, one term at itself twice is going to be the same as 2 times 8 square root of 3 pi minus 4 times square root of 3. Distributing the 2 to each of the term on the inside of the parentheses, I'm going to have 16 over 3 pi minus 8 times square root of 3. But if we were to factor out even more, even though you guys don't have to, but I like to play around with the algebra a lot, we can factor out the greatest common factor of 8. And we're left with 8 times 2 over 3 pi times square root of 3. Let's see, centimeters square. Like that. So this is the final answer of this problem.